guys, today I will present my chemistry assignment, which is green chemistry in the industrial file. Okay, before I explain, let me introduce myself. My name is Ivana and I'm from Environmental Engineering by 2023. So, let's go! So, for the list of content, for the first is definition of green chemistry, 12 principle of green chemistry, definition of green chemistry in industry, difficult of green chemistry in industry, how to solve the problem, conclusion, and that's it. Okay, so green chemistry is a concept that prioritizes the development of environmentally friendly chemical process. From the raw material to the final product, this includes waste reduction, the use of environmentally friendly materials, and energy efficiency in chemical process. Okay, so why green chemistry? Why we need to uh, learn more about the green chemistry? Because it is important enough to discuss in the present to save the future, because it's really difficult for now. So many people do not really care about green chemistry, actually, like in the industry, commercial, or anything like that. So we need to learn more about this. Green chemistry involves the research and development of methods that minimize negative impact on the environment and human health. This includes the use of the safer material, more efficient energy use, and the design of products that can be recycled and or biodegradable. By studying green chemistry, we can create innovative solutions to environmental challenges and keep in the next slide is sustainable. 12 principles of green chemistry. And their explanation, Paul Anastas and John C. They wrote the book Green Chemistry, Theory and Practice, which was published in 1098. In this book, for the first time, Anastas and Warmer introduced the 12 principles of green chemistry. This book also enlarged the influence of the green chemistry movement in the world. Okay, for the first is prevent waste. Prevent like they saying prevention is better than cure. This principle emphasizes careful planning to prevent the formation of toxic waste before production. Beijing begins. Preventing toxic waste is better than throwing and cleaning it up. Okay, and next is maximizing the economic value of an atom. So, this principle promotes the efficient of use of atom in combining chemical in the synthesis process. The goal is to reduce waste to the molecular level by maximizing the number of atoms of all reagents in the production process. And the third is chemical synthesis. Like the first one, this principle advocates the use of chemicals that are not at least hazardous. Right from the start of production, it is expected that chemical synthesis is not harmful to human health and the environment. And the next is design process that involve safe chemical. Not all safe chemical can be used for different product and process. Therefore, if a product doesn't need to use a material that has toxic properties, it is expected that it can be reduced while maintaining its efficiency. Okay, for number 5 is use safe solvent injection condition. Use the safest solvent for each process. Also minimize the amount of salt so as not produce a large percentage of waste. Next is design for energy efficiency. In choosing a chemical reaction pathway, use the less energy intensive one, avoid heating and cooling as well as pressure and vacuum condition. Next, using renewable raw material. Reducing renewable raw material is not only safe but also minimize waste because it usually comes from agricultural product or natural product. Meanwhile, non-renewable raw material come from fossil material such as petroleum, coal, and other mining material. Next is reduce chemical derivative. As much as possible to reduce chemical derivative to reduce reaction states, additional chemical in waste production. Next is using catalyst. The use of catalyst serve to increase selective reduce waste, reaction time, and energy in interaction. Next, design easily degradable chemical. Chemical must be designed to be easily degrade and not accumulate in the environment so as not to cause pollution. Next is analyzing pollution prevention. Perform real-time analysis method to prevent the formation of environmentally hazardous matter. And the last is preventing the risk of accident. Finally, prevent the risk of accident by selecting the chemical used in chemical reaction and improving procedure. So, for the all 12 principles of the green chemistry, by applying green chemistry principle is various aspect of operation, the industry can play a role in minimizing its negative impact on the environment and create products that are more economically and ecologically sustainable. So, green chemistry in industry refers to the design of chemical process and product that reduce or eliminate the use and generation of hazardous. It aims to minimize waste, energy consumption, and environmental impact while maximizing efficiency and sustainability. This approach involves using renewable feedstock, designing safer chemical and process, and minimizing the use of toxic salt and auxiliary substance. Industry implementing green chemistry practice often see benefits such as cost saving, regulatory complement, and improved public perception. In the next slide is how to solve the problem of green chemistry in the industrial field. Okay. Use of sustainable raw material, replacing conventional raw material with renewable or recycled raw material to reduce environmental impact. And the last is use of green catalyst, applying non-toxic and reusable catalyst to improve chemical process efficiency and reduce waste. And the next slide is example of the application of green chemistry in industry. I will explain to you. I have 5 example, but many example, and I choose only 5, and I explain to you. For the first is use of renewable raw material. A chemical plant uses vegetable oil as a raw material to produce certain chemical, replacing petroleum. This reduces depends on fossil resources and reduce the carbon footprint. Next is environmentally friendly production process. A pharmaceutical company adopts a new technology in molecular synthesis that reduce waste and hazardous chemical in the production process of medicine. They will be minimizing the negative impact on the environment. Next, recycle and reuse. A paper mill introduced an advanced water recycling system to process and reuse whatever in the production cycle, reducing the use of fresh water and minimizing the impact of water pollution. Next is use of renewable energy. A manufacturing plant installs solar panel on the roof of their building to generate part of the energy needed for their daily operation, reducing reliance on fossil energy source and reducing carbon emission. And the last is development of environmentally friendly product. A cosmetic company replaced microplastic in their product with natural ingredients or alternative material then that can degrade quickly in the environment, reducing the negative impact on marine ecosystem. By applying green chemistry principle in various aspects of operation, the industry can play a role in minimizing its negative impact on the environment and create products that are more economically and ecologically sustainable. And the last slide is conclusion. The conclusion of green chemistry in industry is that this approach is important to reduce the negative impact on the environment and human health. By developing greener production process, industry can create cleaner and more sustainable products. This makes it possible to reduce the use of hazardous material waste and emissions that are detrimental to the environment, while improving overall efficiency and utilization of chemical substances. His case the human body to be contaminated by a large number of synthetics, many of which are known to be toxic and cancer causing. The substance enter the human body. Tag products that are not mentioned as ingredients in a food product or additivous ingredients in food product or additivous food that is contaminated with chemical, air, water, and dust. In fact, the fetus growing in the mother belly is also directly exposed to chemical through food and drugs consumed by the mother. Medicine consumed by the mother. In the end, many chemicals that enter the food chain and circulate through the world. It has been proved that pesticide uses in the tropics have been found to be commonly found in the Arctic today. Clark 2000, 2005. Substance fire strain in furniture and electronics are now being found in the body of mammals that live in the ocean. So, today we want to learn more about the green chemistry. Basically, in the green chemistry approach is an attempt to apply the principle of eliminating and reduction of harmful compounds to the design, production, and application of chemical products. The green chemistry approach seeks to minimize hazardous substances, the use of safe catalysts for chemical reaction and process, the use of non-toxic reagent, the use of safe catalysts for chemical reactions and process. In chemical process, the use of non-toxic reagent, the use of renewable resource increase efficiency at the atomic level, and the use of environmentally friendly sulfates atomic level, and the use of environmentally friendly sulfates ever to apply green chemistry to produce industrial products for building and replacement of hazardous chemical used in various industries and health have been made. Various regulations regarding the application of green chemistry at the world and Indonesian level have been made. Strict supervision is needed for the application of this green chemistry approach to prevent harm to health and the environment. There are still many efforts need to be made to improve research, education, policy, and application of chemistry, especially of the application of nanoparticle for health. Green technology principles are based on the development of green engineering by Paul Annas and Julie Zimmerman. These engineering principles describe a generic chemical process or product with 12 principles HAS 2018 as follows. Inherent rather than circumstantial. Designers should ensure input and output of material and energy are non-hazardous. Prevention rather than treatment. It is better to prevent waste than to treat or clean up waste after it is formed. Design for separation and purification operations should be designed to minimize energy consumption and material use. Maximize efficiency. Product, process, and systems should be designed to maximize the efficient use of mass, energy, space, and time. Output pull versus input push. Product, process, and system should be output pulled rather than input push through the use of energy and material. Converse, complexity, entropy, and endurance. Complexity should be seen as an investment when making design choice on recycle, reuse, or beneficial disposition. Durability rather than immortality. Design goals are aimed at a long-lasting product life rather than single use. Convert complexity, entropy, and endurance. Complexity should be seen as an investment when making design choice on recycling, reuse, or beneficial disposition. Durability rather than immortality. Design goals are aimed at long-lasting product life rather than disposable and perishable. Meet need, minimize excess. Design for necessary capacity or capability should be considered a design flow. One size fits all. Minimize material diversity. Material diversity in the multi-component product should be minimized for easy disassembly and reprocessing. Integrate material flow and energy. Product, process, and system design should include integration and interconnection with available energy and material flow. Design for commercial afterlife. Product, process, and system should be designed for post-use commercial performance. And the last, renewable rather than depleting. Material and energy input should be renewable rather than using extractable and non-renewable resources. Okay, I think it's all from me, and I hope from my presentation all of you guys can take and you can apply in your life. And don't forget to save and care about our earth and our environment, because we must care about our environment and our earth. Okay guys, I think it's all for me. Thank you.